Section 30 is entitled Introduction to Functions of Several Variables. Suppose you were told that f of x comma y is equal to x times e to the y. And we're going to do evaluations first. What is f of 5 comma 0? X is the first number, y is the second number. X, e to the y. I write x this way and I even write y that way. In the bracket for x I put 5, 0 for y. It's 5 times this. Well, 5 is 5, e to the 0 is 1, the answer is 5. You wanted to do f of 2 comma negative 1. It's x times e to the y. X is 2, y is negative 1. 2 is 2, but e to the negative 1 is 1 over e to the 1. 2 times 1 is 2 over e to the 1, which is just e. Suppose you're given a different function. F of x, y, z. This is x plus y plus z square root. That is, add those three numbers and then put a square root above it. If you can say it in words, then it's easy. Add those three numbers, add these three numbers, put a square root over it. It's exactly what it says here. So f of 3, 4, 7, you add the numbers, you get 14. It's the square root of 14. And if you want, you can say x plus y plus z square root. X is 3, y is 4, z is 7. That's the square root of 14. It's the square root of 14. You wanted to know f of 7, 2, 5. In this case, you add the three numbers, you get 14. Oh, you get the square root of 14. It's not always 14. Just follow the rule. Instead of there being just one unknown, instead of it just being a function of x, it can be a function of 2 or 3 variables, or 23 variables. Suppose you're told that f of xy is equal to the square root of 4 minus x squared minus z squared. Now, just like when you had f of x, we call that y. After x comes y in the alphabet. If you have f of x comma y, this is equal to x, y, and then z. Generally, you let z equal f of x, y. So z is equal to this. Of course, this meant this was supposed to be y. But the only letters I should see to the right of the equal sign are x's and y's. Sorry about that. I had z on my brain. Okay. Now, keep in mind that the right-hand side is always not negative. It's either positive or 0. That is, z is not negative. If I square both sides, I get z squared is equal to this. bringing the x squared and the y squared to the left-hand side, I get this. But of course, z is greater than or equal to 0. Because these last two equations allow z to be negative. I mean, if x was 0, when y was 0, when z was negative 2, 0 squared is 0, plus 0 squared is 0, plus negative 2 squared is 4. And yes, that does give me 4. That is, based on this equation here, 0, 0, negative 2 is a point. But in the top one, it wouldn't work. Z can't be negative. Because z equals this. And sorry, but that ain't negative. Especially when x and y are both 0. So we just have to keep the bookkeeping on that. Z is greater than 0. Now, let's just talk about what we have here. I didn't mean to erase this line. What we have here is a sphere where that's r squared. So that means r is 2. It's a sphere of radius 2. But it's a hemisphere because we won't allow z to be negative. We will not allow z to be negative. So basically, it's just the upper half. I don't know how to draw it well. It's just half of the sphere. I guess we really shouldn't have anything below that. Yeah, actually, that's not so bad. It probably should have been a little bit lower. It's just half of it. It's half, the upper half of a sphere. It's just the upper half. Something like that. Where this is 2 and this is 2. And I guess I really should be crossing there. It's very difficult, especially for me, to draw two-dimensional objects on a three-dimensional, possibly I said that backwards, a three-dimensional object on a two-dimensional board. But hopefully you get the point. It's the upper half of a sphere. Okay. So that was the problem. To describe the function, to describe the graph, and to graph it. Now, we should also talk about the domain. We should also talk about the domain. 4 minus x squared minus y squared. Well, the domain is what's underneath the square root sign, that's a minus, should be greater than or equal to 0. Bringing the x squared and y squared to the other side, that's positive x squared plus y squared. We get that x squared plus y squared must be less than 4. The arrowhead, I call this an arrowhead, is pointing to x squared plus y squared. And it still is. X squared plus y squared is less than or equal to 4. That's only in the xy plane. That's just a circle of x squared plus y squared equals 4 is just a circle of radius 2 in the origin, centered in the origin. But it can be less than. That means inside. That's your domain. That is your domain. X's and Y's this should be Y here. Sorry. The X's and Y's that you pick, you can only pick XY combinations that lie inside the circle. For example, if you pick X and Y's so that x squared plus y squared is equal to 16, let's make it 32. Okay, that doesn't live up to this. Well, any points that you pick, like x equals 4 and y is equal to 4. You square 4, you get 16. You square it again, you get 16. You add them up, you do get 32. Well, you can take out for 4. So you'll get 4 minus 4 squared minus 4 squared. This is the square root of negative 28 if I'm not mistaken. But I'm not mistaken that it's negative. So you have 4 and you take away more than 4, and then you take away some more, you're going to be negative. And this is undefined. So 4 is not in the domain. The domain is all points in the xy plane inside a circle of radius 2 centered at the origin. X squared plus y squared equals 4 is a circle centered at the origin whose radius is the square root of 4 or 2. You want to be less than your inside. If you were greater than, you would have been outside. Okay. Now, what about the range? So we talked about the domain. Now let us talk about the range. In this case, the range is not the y values, but rather the z values. The range is the z values. Remember, this is z. F of x, y is z. So, if you pick x's and y's that are allowed, that is inside this circle of radius 2 centered at the origin, what kind of y values, z values can you get? And I can factor out the minus sign. It's 4 minus x squared plus y squared. Now, we know that this piece right here is less than or equal to 4. It fluctuates between 0 and 4. So 4 minus x squared plus y squared, the least it will be is 4 minus 0. That's the least it'll be is 4 minus 4. It'll be the least when that's the biggest. The biggest this will be is when you take away the least from 4. That is when you take away 0. So 4 minus x squared plus y squared is in between 4 and 0. So the square root of that is in between the square root of 0 and the square root of 4. That's your range. The range for z is z, because this is just another name for z. Z is in between 0 and 2. That's your range. You need to be mathematically mature enough to handle these type of problems or questions. They tell you that f of x comma y is equal to e to the x over y. That is, z is equal to this. Now, I'm not exactly sure how to graph this, but nonetheless, let's talk about the domain. A power of e can be anything. Okay? The power can be anything. It isn't like you can't raise e to a negative number, or you can't raise e to the 0. E to the 0 is 1. You can raise e to any power, but the power has to be well defined. The denominator cannot be 0. That's the only restriction. The denominator cannot equal 0. Okay, you can't divide by 0. What's e to the 7 over 0? Well, it's e to the, I don't know. I don't know. Because I don't know what 7 over 0 is. Well, if you don't know what you're raising e to, then it's not well defined. E to the I don't know. How much is it? You don't know. It's undefined. Okay. Now for the range. Now, x over y can be any number. And I can get it to be 11.2. I can get x over y to be 11.2. The easiest way is to let x be 11.2 and let y be 1. I can get the power to be anything I want. If I want it to be any number k, I let x equal k, I let y equal 1. Or I can let x be 2 times k, and I'll let y be 2. After all, when you divide 2k by 2, you get k. Of course, I can let k equal 3, x equals 3k, and let y equal k. I meant to say 3. I can let x equal any number times k, and let y equal that any number. Therefore, that way x over y equals k. That is, I can get x over y to be any number I want. And e to the x graph, for example, y equal e to the x goes like this. It goes from just above 0 up to infinity. And that's the range. The range is z. Z can be anything above 0. Because whatever this is, and like I said, it can be anything above 0, and it equals z. It says this in the box equals z. Z can be anything bigger than 0. And that's the range. The domain is x can be any number, y cannot be 0. Now if all you say is y cannot be 0, well that means x can be anything. After all, y not equaling to 0 means y can be anything but 0. Suppose you were asked to sketch this. This is the problem that I think we just talked about. Well, maybe not. Suppose you wanted to sketch that. Now again, z must be greater than or equal to 0. Because you square x and you square y and you add them up, you won't get negatives. And even if you did, you can't take the square root of a negative number anyways. So if I square both sides, I get this. But here, this would allow z to be negative. Because when you square it, it'll be positive, like the right side is. The right side is always positive. But we're only dealing with z bigger than or equal to 0. Now, what you need to realize is that you could fluctuate z. If z is 0, if x squared plus y squared is 0, that means x and y is 0 and z is 0. If we started off with, if z is 0, that means x squared plus y squared equals 0 squared. There's only one point on x squared plus y squared equals 0. X must be 0, y must be 0. The premise was z is 0. That's the only point. Now if z is bigger, z is 1. Well, 1 squared is 1, and that equals to x squared plus y squared. But that's a circle of radius 1, where z is 1. Imagine drawing a circle of radius 1 on the x, y plane, but then bringing it out. The z-axis is coming straight out the board. Bring that circle the positive z-axis. Bring that circle 1 unit off the board. Then if z is 2, you get that x squared plus y squared equals 2 squared, or 4. Well, that's a circle of radius 4. But that came further out from the board. And then if z is 3, you get x squared plus y squared equals 9. That's a circle centered at the origin of radius 3. But it comes out of the board 3 units. And basically, what you're going to get is a bowl like this. When z is 1, there's a circle of radius 1. When z is 2, has a circle of radius 2. When z is 3, you get a circle of radius 3. Why is that? Because z is 3, z squared is x squared plus y squared. But the square root of that is 3. The radius is 3. And there it is. There is your diagram of the top equation. Now, if I were going to graph this one, the big difference is that z can be negative. And we get the same diagram upside down. But since z from the beginning can only be positive, ain't going to graph that. Going to erase it. Okay, so there's your graph. You really should be able to handle that. Think of level curves. What happens when z is 0? What happens when z is 1? What happens when z is 2? Hopefully you'll start seeing it come together. You have that f of xy is equal to the square root of 25 minus x squared plus y squared. Even if they don't put it in brackets, I would. That is, if you were told that f of xy was the square root of 25 minus x squared minus y squared, I would write it like I did below. And I would call f of xy z. Instructions here are to look at the level curves. If I square both sides, now remember, this is positive. That is, z is positive. When you square both sides, fair enough. The right side is still going to be positive. Because the left side is positive this time. The left side is positive. So you can only pick points and make the right side positive. So the right side is positive, but the left side can have z negative. And after all, if you square a negative, you get a positive. That is, these two equations are not the same unless you add on that z has to be greater than or equal to 0. Then they're the same equation. Now, if I bring the x squared y squared to the other side, they'll become plus. X squared plus y squared plus z squared is 25. This is, and that's r squared. That's r squared. So r is 5. It's a sphere centered at the origin of radius 5, except it's only above the xy plane. Above or on the xy plane. If you're below the xy plane, that means z is 0. Now, like I said, they wanted us to do level curves. I mean, I would still come to this equation here. Actually, I would use that x squared plus y squared is 25 minus z squared. Now, if z is 0, you get the biggest possible circle. Is where the radius is 5. If z is 1, then you get x squared plus y squared equals 1 squared is 1. 25 minus 1 is 24. It's right above the xy plane is where z is 1. Right above the xy plane, and the circle is a little bit smaller. And then when z is 2, copying this equation, 2 squared is 4. 25 minus 4 is 21. So you get this. It's a little bit higher on the z-axis, but the circle, still a circle, but the radius is a little bit smaller. It's the square root of 21. It's just below 5. If z is 3, then you get x squared plus y squared is equal to 25 minus 3 squared, which is 16. Now the radius is 4. You keep getting circles, one circle above another, except the circles are getting smaller and smaller. If this is the z-axis, you have, and here's where it's 0, you have the biggest circle. Radius is 5. And then at 1, well, let me just have this in front of me. When the radius is 1, the circle is a little bit smaller. When the radius is 2, the circle is smallest. When z is 2, I meant to say. When z is 5, you get x squared plus y squared is equal to 25 minus z squared. But z squared, 5 squared is 25. 25 minus 25 is 0. So when z is 5, you have a circle where the radius is 0. That is, you just get that one point. And there is your curve. There is your curve. This is the z-axis. Here is 5. And this length is 5, and this length is 5. There it is. That is three-dimensional. There it is. And their y-axis goes this way. Here's the origin. And the x-axis, so let me put y, and the x-axis comes out from the board. And there it is. It just has circles. It just has circles. And as it goes up higher on the z-axis, the center of each circle is the z-axis. And basically, as you go up the z-axis, their circles get smaller and smaller. Here's a similar one. Suppose that f of xy is equal to x squared plus y squared. That's z. That is, z is x squared plus y squared. Now, this can't be negative because x squared plus y squared can't be negative. Okay, so we know that z is only bigger than 0. And if this is the z-axis right here, and here is 0, well, when z is 0, you have x squared plus y squared equaling 0. That's just the one point, 0, 0, 0. When z is 1, x squared plus y squared equals 1. That's a circle of radius 1. When z is, say, 4, x squared plus y squared equals 4. That's a circle of radius 2. And then when z is 9, you get a circle of radius 3. So basically, just getting bigger and bigger and bigger. There is no cap on this one. It goes bigger and bigger. And here is a y-axis, and the x-axis is parallel, is perpendicular to the y-axis, the right angle. It's the right angle. You definitely should be able to draw curves like that, or at least see that it's going to look like that. We want us to sketch the level curve f of x, y, z equals c. And they'll tell us c, and they'll tell us f of x, y, z. F of x, y, z is x minus 2y plus 3c. I meant to say 3z. That's f of x, y, z. Usually, x, y, z, what comes after z is w. So w equals x minus 2y plus 3z. This is 4 dimensions. We have an x, a y, a z, and f of x, y, z. And when we had f of x equal y, this was 2 dimensions. When we have f of x, y equaling z, that's 3 dimensions. What we have here is 4 dimensions. And the value of c is 6. C is 6. So that means z is 6. Because f of x, y, z, I meant to say w, f of x, y, z is w, which equals 6. So they want us to draw just this. They want us just to draw that. Just draw it when it equals 6. Now that's a plane. Whenever you have a number times x plus a number times y plus a number times z equaling a number, this is a plane. Now, of course, any one of these constants could be 0. Right now, the way you would draw this is by finding the intercepts. We've done this before already. If y and z are 0, then x is equal to 6. Okay, there's 6. And that's where y and z are 0. I started at the origin, I just went 6 on the x-axis. I didn't move in the y nor z direction. Okay, now let's talk about y. Everything else is 0. So negative 2y is equal to 6. That means y is negative 3. Now let's just allow z to be around. Positive 3z is 6. That means z is 2. There it is. It's all the points that lie on that, say, triangle. And of course, these walls of the triangle could get expanded. Now, I don't like the way that looks, so let's just do it again. Z is, and then y is negative 3. The x crosses at 6, and it crosses the z-axis at 2. Z. So it's all the points on that triangular region. All the points are in there, and you could make the triangle as big as you want by expanding the sides. 3 points define our plane. 2 points define a line. 3 points define a plane. So that's why finding 3 points was enough. Now you couldn't possibly draw that 4-dimensional picture. You can only draw it for different values of W. When W is 6, it looks like this plane. When W is 7, it looks like that plane. And on that note, that completes the section entitled Introduction to Functions of Several Variables.